Okay, so this was actually the only question asked was one of the ones with r squared. So I decided to do r equals cosine theta and r squared equals cosine 2 theta. And you can see I sketched it, or I graphed in Desmos and then screenshotted it, put it there, and I labeled the points A and B. So what we're going to do now is find the simultaneous solutions, so set them equal. So I'm going to plug in the one on the left to the equation on the right. So this is your first and your second. So I'm going to plug in cosine theta into r. So I have cosine theta squared equals cosine 2 theta. I'm going to go ahead and just write this as cosine squared, and I'm going to use the double angle identity for cosine here, which is that this would be 2 cosine squared theta minus 1. You could do the intermediate step, where you have cosine squared minus sine squared, and then you replace sine squared with 1 minus cosine squared, and you end up here. Okay, so then I'm going to move that cosine. Let's move this 2 cosine over. So subtracting 2 cosine squared from both sides, I get negative cosine squared theta over here equals negative 1. So I have cosine squared theta equals 1, dividing both sides by negative. And then I am going to take a square root on both sides. So cosine theta equals plus or minus 1. When you take a square root, you end up with needing to adjust for plus or minus there, that it could be positive or negative. Sorry, give myself some space here. And then we want to figure out where that's true. So theta, where cosine is positive or negative 1, that would be at 0, pi, and then 2 pi. But if you include 0, you don't need to include 2 pi, so we'll just stop there. And then what we want to know is, okay, well, what's r? So what you do to find r, you're going to plug in those angles. So cosine of, let me write this down. So r equals cosine of 0 for when theta equals 0. Cosine 0 is 1. So your ordered pair would be 1, 0. And then you want to solve that second, plug it into the second one, it will give you the same thing, because that would still be just cosine of 0. So when theta is pi, plug that in, so you get r equals the cosine of pi. And then this is going to be, cosine of pi is negative 1. So you're looking then at the ordered pair negative 1 pi. Both of those are at A, right? Negative 1, go out negative 1, rotate around pi, that puts you here. Go out 1 and rotate none, that puts you there. So both of those are at point A. So then you got to say, okay, well, what about B? Well, B is a this would be a non-simultaneous solution. And we want to use our eyes to see this, that B is on the origin. So R has to be 0. So then let that be true in both equations and solve. So for the first one, we have 0 equals cosine of theta. Cosine 0 at pi over 2 or 3 pi over 2. And then for the second equation, you have r is 0, so r squared is still 0, equals the cosine of 2 theta. So then you want to figure out where that is true. So then 2 theta equals pi over 2 plus 2 pi k, and 3 pi over 2 plus 2 pi k. And then you want to divide everything by 2, so you get theta equals pi over 4 plus pi k, and 3 pi over 4 plus pi k, and then you want to get all four of those angles. So theta would be pi over 4, 3 pi over 4. Then you want to add pi to each of them. So 1 and 4 is 5, and 3 and 4 is 7. Okay, so that's kind of a mess, but we have this then. Have 0 and pi over 2. Oh, that's way too big of a parenthesis. 0 pi over 2, 0, 3 pi over 2. And then a big slash and all four of those. So 0 pi over 4, 0, 3 pi over 4, 0, 5 pi over 4, and 0, 7 pi over 4. And all of this together makes up your point OB, not Z, B. So that is how you do the R, one of the R squared ones.